Yeah. So what else do we have? So then the same thing now that we have done with the other one. In order to open up this stacked frame securely and without losing the content of the resistors, we have to put the resistors that we have used. We have to push them and then put them back. So we have used the resistor 10 and the resistor 11. So we have to push them. Resistor 10 and resistor 11. Push the resistor 11. We have to assemble that. So this the assembly. So if we disassemble that, and then we have to put them back. So to put them back, put can just use that. Put the resistor 11. This is the resistor 11 and the resistor 10. And I suppose the opcode for the return is 30 and 31. Yes, I suppose that's one. That's right. Okay, so we get that. Yeah, if we disassemble that, we see pop processor 11, pop processor 10, and we return back. Now this code is supposed now to brute force for the password that we have. So here's the idea. So we will be passing that code. So we need to first, as always, know the size of that code. Divided by 2, which is 0x24. So that's why, guys, I have choose 24, because basically now the size of the code is 0x24. So um size of the code is 0x24. So basically if I want to load the code at 5000, I need to load the data that I will be using to brute force the key at 5000 plus 24. So this is why I have chosen this address as the place where I'm gonna be loading my data, or the first potential key that we will be trying. Since we have leaked now the data of the RAM, I want to first write a code. So this is the code, and then I will be loading the first potential keys, or the different kind of combinations that he will be using, or the different bytes that he will be using, um, exactly at this address. I don't know if you understand that or not, but this is how we are going to be doing this. So the first thing that we'll be giving the loading address, and then we will be going to give 0x24 now, 0x24 for the code, plus 0x40 for the data that we will be using. So that's a 100. So if we try to convert that in hex, it's going to be 64. So the size of the final payload that we will be sending is 64. So we will be sending the code. So this is the code. Let me go back. So this is the code. This is coded. Uh, brute force. Brute force the SRAM. So this is we'll be using to brute force the SRAM. So we'll be using that, and then we will be also giving this data, which is the actual content of the RAM. But we need obviously to not get the zeros. We only need to get the first ones, which are those bytes, which is the actual data that we will be using. And once we do that, we can send that to brute force the door. Yeah. So if you wanted to brute force the door, let's try to send this data. And as you can see, the door is unlocked, which means that the brute force that we have done has came to has came to a solution, which means that the password is obviously in the data that we have leaked from the memory, and the door is unlocked. But in using this way, we didn't yet solve the challenge. Why? Simply because if I go into, for example, solve, I cannot leak the hashes. I cannot leak the hashes of the memory. I cannot leak the RAM because I'm not having the memory in front of me. So there is only, well, let's say there are two ways to solve this. Either by using the function that he is using, which is this one to print the hash. In order to use this one, I need to mimic the code that he is having here. Exactly this one. I need to use this code in order to print the hashes that I have used in order to dump the file, and then crack the password again. But there is another solution that we can actually take, which is trying to figure out exactly the offset of the password in the memory. Why? Simply because every time as you can see, as we refresh the page, there is a new hash, which means there is a new data in the RAM, which means there is a new key in the RAM, which means that the key is getting randomized each time, which means that if we find the offset of the password inside of the RAM, then I can just try to leak the hashes from that password. And since the password is 16 bytes, that means that I have to leak 16 hashes. Once I leak the 16 hashes, all I have to do is just crack the 16 hashes and get the password. And once I get the password, I should just send. So I can just, for example, write a simple code that passes the password, the right password, to the challenge to finally unlock the door. This is the way we can do this. So here's the idea now. The next step that we need to do is to find the offset of the password inside of this data. Inside of this data, I need to find the offset. Okay, since the data has changed, I need to again retrieve the content of the memory. So 5000 3E, this code. We need to get again a dump of the data. Let's check the hashes if they are the same. 10D, 5C, so it's the same. So this is the data. So let's try to brute force again on that data. How much size do we set? So 64. So this is the code. And now we have to give him the data that he will be using to brute force. We send that. And the thing is, guys, if you just came back a little to the code that we have used, so what is exactly the address of the password inside of the data is basically pointed to by the register 11. So the register 11 is having the first address of the first potential key or the first potential password that we can use. And since the brute force is gonna be using this register 11, I suppose if we go back a little and try to see the content of the register 11, we see that the register 11 has the offset 5054, which means we basically, in order to unlock the door, we basically just give a pointer to the first character, and then he will be getting the 16 bytes before that character, which means that once we have 5054, to get the actual offset of the password, we need to just subtract that from the first one, just to know the address. So the offset should be 0x 5040 54 minus 5000, 24. So if we do a hex and we add the 0x, obviously, so the offset of the password is 0x13, which means that the password is away from 0 at the offset 0x13 in the SRAM. So the password is living in at the offset 0x13 inside of the RAM. Now here's the thing. Now once we know that, we can now directly try to dump these 16 hashes that are at the offset 0x13, which are the hashes of the password, of the right password, and then try to crack them locally, and then get the right password, obviously, and then give it back with another code that we can write. So to do that, I have, just to gain some time, I have written that, which is this program. I have tried to write that locally before just recording the video. We can just disassemble that directly. So what am I gonna be doing, guys, actually, is just let me get that into the Sublime, just for you to explain exactly how I did that. So yeah, so this code is actually the same code as the one that is in the program loader. Take a I just took a copy of it and just used it. This is basically the code that is responsible for just printing the hashes. What else do we have? Just a second. Yeah. So here's the thing. I have just moved a counter just to say this is a counter just with a 0x10, which means that I'm gonna be trying 16 bytes, which means that the password size is gonna be 16. What else? So this is the address of the destination where he's gonna be just putting those hashes. This is just to tell him that he's gonna be using each time an offset of jump equals to 1. And this is just to tell him that the offset of the password of the right key or password is at 0x13. And then what I will be passing, this is basically the SHA function that will be hashing. So what he will be having is he's gonna be taking the destination where he's gonna be hashing. The register 5 will be containing the offset 1 just to tell just to tell him that he's gonna be hashing 1 byte, and the starting point he's gonna be hashing from is the 0x13, since we knew that the password is at that offset. Now just after hashing that, he's gonna be using the obviously the code that I had from the program loader in order to print for me the hashes or the hash of that bytes. Now after doing that, we have to increment the R6, which means that we will be trying to see the next potential password. And we have to decrement the R8, which will be containing obviously the counter, since we are trying 16 bytes, since we know that the password is 16 bytes. Once we do that, we have to jump back to this address, which is 5C, which is obviously this one, just to try again another password. Try to obviously just hash another password and see if it's gonna be. We are not actually we are not actually trying to test if the password is right or not. Basically now I'm trying to leak again the hashes of the right password. The last time we have tried to do that for the whole RAM, but right now we knew that the offset of the password is at the 0x30, which makes it more easier for me just to leak the hashes at that offset and then try to crack them locally. So let's try to do that. So if we try this code, guys, so if we try this code, which length is 60, Um, do we have to reset something? So as you can see, those are the hashes of the password. So this is the hash of the password. Now, once we have the hashes of the password in front of us, now the thing is now we can just convert those hashes back. So we can, for example, now write a code that can help us just crack down those hashes and get back the right password that we wanted to have. So you can create, for example, a password hash that's gonna be um, obviously those ones starting from the 9C. Please debug payload is not with them. We have the convert hashes to bytes. We don't have to create it another time. What else? So we can just create a main. We can just create a main. We have the hashes. For example, a hashes list that has the password hashes. We obviously take them. We try to divide them actually. Let's try to divide them. But obviously we don't have to do it, so since the range is 16. Next we try to password list or password bytes. Try to convert this hashes list, and then the password should be for B in password bytes. We can just create a hex for that password, and then we can just print the password that we had after just cracking it. Non-type object cannot be written as like that. Hmm. Let me just try this out. There's a problem. Non-type object cannot be. Maybe because it's. Wait a second. Maybe because it's. Wait a second. Maybe because it's not the same. He's returning a non, which means. Wait a second. We have to print that. Let's try to print that. There's a non. Which means that the convert hashes to bytes is not working. Let me just print that too. The hashes are working well, but hmm, hmm. I think because I'm trying to. Let me try this one with just none. If you try to lowercase this one, to lowercase online. I want to just make sure that uh yeah, like that. Maybe just try like that. Yeah, the problem because it is uppercase. I need to lowercase them. Hmm. Um. Is there any ways to make it to upper? Just, just upper them directly. Um. I need to check how I can do this directly in Python. So, I need to just convert the hashes to gay. So, how to uppercase in Python? You can just get that. Is there any to? I think it's working well now. Hashes list. Maybe you can just hashes list equals to c dot to c dot upper for c in hashes list. Is that gonna be working? Hash is missing one required, which is hashes list obviously. Same problem, none. Hmm. Is it lower? Now it's working. Okay. Okay, this problem was just make it lowercase. This problem. What the fuck? Ah, the none at the end. Okay, let's suppose I don't have to add the none. If it's not none, if B is not none, can you print it? Okay, I don't know if that is 16 bytes or not, but I suppose it should be 16 bytes divided by 2. So 15, it's not. Okay. There might be a problem here. Let me a second. I think I have written that before. Let me just go back a little. So yeah, let me just try that out. So yes, this is a password. Now if we try, guys, to write now. So this is the password that we have now. The rest is that we have to write some code that can write for us. That can write for us, for example, just how can we just open up the door directly. So to do that, we can just basically just push, for example, just push the password immediately. For example, I suppose the password, since it's a 16 bytes password, so we will be pushing the code at the, we'll be pushing the password, obviously, that is in the address 5010. So this is the password, and then we will be pushing 0x42, and then call the obviously interrupt, uh, obviously call the interrupt, and add 4 to the stack pointer, and then return. We have to again compile that, assemble that. I'm sorry. Okay, there's a problem Forgot one. Everything is cool. That's why that we have to. Okay. So what else do we have? So we have to return, which is 13, 14, or 41, I think. This is symbol. Yeah. So this is the code. So when we try that out, we obviously gonna be loading that address, and it's gonna be, what is the length of that code? It's 32 divided by 2 divided by 2, 16. Okay, which is 0x10. And the other one, which is the password, is also 16, which means that we need to give 0x20. So this is the code that we'll be executing, and this is the password. And the okay. Hmm. Oh yeah, I think because we did I correct that? Yeah, correct the wrong password. Yeah. So we try again. 20. Program that I will be using this one. Password that I will be trying on is that one. It's a new password. Yes, the door is unlocked. Now let's just solve that. Um, so we have to dump the data. Just dump the password. So this is the password. We dump it. We try to crack the password. We can just add directly another code. Uh, just gain some time. Yeah. I think there's a problem. Let's try again. Yeah, I remember this problem. So basically, this problem is when the RAM is containing more than 40 bytes, 14 bytes, I'm sorry. It's when it's containing more than 14 bytes of data, the password is not there. So um, I need to refresh to get a new password just to bypass um, just to get a password basically. When we have, for example, the RAM is having more than 0x400 um, usable data, it means that the password is not there. But when we have 0x40, that means that we have the password there. This is the thing that I think we are having, or that I have dealt with when I tried to solve the challenge. It's actually, there is a lot of there is a lot of games actually when I was solving this challenge, which is really interesting. Um, yeah, so let's try to crack this one. Hmm. Let's try one more time. Okay. I think this one will work. Nope. Let's try to solve it. Hmm. Let's try this one. Yeah, this one worked. Okay, I think this is an interesting challenge, to be honest, guys. I had really fun solving it, and there are some still some holes. Just to understand that, for example, the last thing that I tried when I tried several times was actually really intimidating. At first, I thought that my work is not working. I thought my code is not working, but at the end, it was like after some several tries, I just figured out that when the RAM is having some specific data inside of it, that means that the password is not there. You have to refresh just to get back, just to understand that the password is not there. You have to go back. And when the RAM is having 0x for 40 bytes of data, fusible data, that means that the password is there. Well, it was a fun challenge. I really enjoyed it. It took me 2 weeks to solve it, but I didn't give up, to be honest. And I hope you learned something new. There's a lot of automation inside of this challenge. We automated the code using those two scripts, obviously, and we wrote a lot of assembly. we we actually built a lot of gadgets together. But yeah, we had fun. So yes, don't forget to follow me on Twitter. Don't forget to subscribe if you learned something new. And yes, join me on Discord too if you want. Goodbye. Ciao.